Hello everyone. So in today's lecture, we are going to see about electric flux. Before starting electric flux, let us see what do you mean by flux. Flux is a Latin word which means to flow. To flow. To understand the electric flux, let us consider a flow of liquid with velocity v through a flat surface area having area A. In the direction normal to the surface, which means that here the direction of area is normal to the surface in this direction. The rate of liquid is given by the volume crossing the area per unit time, which is equal to B into A, represent the flux of liquid flowing across the plane. So here the flux of liquid flow is equal to E into A. By mistake, it's not E, it's V. It's V into A. Now, in this case, the flow of liquid is maximum, as all the liquid particles are equally penetrate in area A, and the flow of liquid is minimum in the third case, because all the liquids are flowing over the surface. No liquid is crossing the cross-section area. So the flux is entirely depend upon the placement of the area. Here we considered surface area A as a vector whose position and direction both are important, and the direction is given by A into N, direction of area vector. Where N is the unit vector along the outward surface normal to it. Unit vector along the surface normal to it. So let us suppose we have the surface is given like this. So its direction, area vector direction, is given by in this direction, which is normal to the surface. So in this case, the first case, the flux is maximum. In the second case, the flux is somehow less than the first case. So in this case, it is given by B into A cos theta, where theta is the angle between A and B, and in this case the flux is 0, as no surface of water is crossing through the area So if we replace this volume of a water with electric field lines, then we call it electric flux. As we discussed in earlier topic, that flux is a Latin word which means to flow. So flux can be referred as a flow of a stream of anything from one point to another point. So when we talk about the electric flux basically indicate the number of field lines crossing through the surface of area A. So basically we can say that flux is a product of a magnitude of electric field and area vector A. So we can further write EA cos theta. Here here area is taken as a vector quantity, and whose direction is taken normal to the surface. It is above to the normal, it is below to the normal. And when we took area as a vector, then its magnitude is equal to the surface area of at its direction is normal to the surface. Magnitude is equal to surface area and direction is normal to the surface. And electric flux is a scalar quantity and its unit is given by Newton per coulomb meter square or volt per meter. I hope you get the intuition about electric flux. So next we are going to see a question. The question says that we need to find out the electric flux through a surface, through a sphere that has a radius of 1 meter, carries charge of 1 microcoulomb at its center. The question says that we have one sphere is there. At its center, we have 1 microcoulomb charge is there. And we need to find out the electric flux through the sphere. Electric field lines is coming out like this. Since charge is a positive, since here the charge is positive, so electric field lines is coming out from it. So we need to find the total number of electric field lines coming out from the sphere. So here Q is given by 1 microcoulomb and radius is given 1 meter. So we need to find out the electric field intensity. It is given by Q upon R square. Or putting the value, we get 9 into 10 to the power 9, 1 into 10 to the power minus 6 upon 1 square. On solving this, we get 9 into 10 to the power 3 Newton per coulomb meter square. Since we have obtained the electric field lines, that is equal to this. Now we need to find out the electric flux. So in order to find the electric flux, we need to determine the surface area of the sphere. So surface area of the sphere is given by 4 pi r square. So it is given by 4 into pi and the radius is 1 meter. it is equal to 4 pi. So the flux is EA cos theta. So here we need to find what is the value of a theta. So generally, if we took out the strip of a sphere, it is given like this. Cutting out the strip from the given surface. So it is given by like this. If we see the electric field lines is coming out from center is like this, and here this is a surface area, and the area vector is taken normal to it. It is N and it is E. So both are in the same direction. So we can say that theta is equal to 0 degree. So cos theta is equal to 1. On putting the value, we get 9 into 10 की power 3 Newton per coulomb meter square into here the area is 4 pi meter square. On solving this, we get 36 pi into 10 की power 3 Newton meter square per coulomb. So this is the total number of flux coming out from the sphere. Let us see another question. So in the question, it is given that electric field is oriented in the x direction. Electric field oriented in the x direction. Find the net electric flux through the surface of a cube of edge L oriented along as shown in the figure. So in this case, we need to find out the total number of flux from this surface 1, surface 2, surface 3 and surface 4. So first we will see about surface number 1. At surface number 1, we say that it is equal to E into dA1 cos theta. Since for the surface number 1, the area vector is like this and electric field is like this. So angle between them is 180 degree. So we can say that E cos 180 degree dA. It is equal to minus E, and when we integrate dA, it is equal to L square. So it is equal to E L square. When we see surface 2, it is again E into dA2 cos theta. So here the area vector is like this and electric field is in the same direction. So angle between them is 0 degree. Theta is equal to 0 degree. So we can say that E cos theta is equal to dA2. So on solving this, we get EL square. So it is considered equation number 2. It is considered equation number 1. Now we are going to see surface number 3 and surface number 4. So in this case, the area, vector and electric field, so they both are perpendicular to each other. When they are perpendicular to each other, so in this case, cos theta is equal to 90 degree. So cos 90 is equal to 0. So from the surface 3 and surface 4, the flux is equal to 0. And the flux is 0. So we can write the total flux is equal to phi 1 plus phi 2 plus phi 3 plus phi 4. On putting the value of each phi, we get minus EL plus EL 0 plus 0, that equal to 0.